please hit subscribe.
This is clearly a variable separable differential equation. In fact, we don't have x appearing on either side, and so we can just go on with our usual tricks for variable separable differential equation. Now let me just write that down again. Now, if the right-hand side, 1 minus y squared, is not equal to 0, note that this is important because in the next step we will be dividing by 1 over, or rather by 1 minus y squared. So if that is not equal to 0, we can do the division. And now we have so let's just do the integration. And in fact, this integral here is quite easy, so let's just do that. Then I'll just put that on the other side. Now we can actually integrate this expression using partial fractions. That's what we'll do. And we know this very well, so I'll just skip the steps. And if we multiply both sides by 2, we get the following. Here we have C1 equals to C sub 0. Now let's use both sides as the exponent to our exponential function, and we get and then let's remove the absolute value symbol, and we get now here we have C3 equals plus minus e raised to the c sub 1. And we notice that this means that C3 is not equal to 0 because this expression never equals 0. Then we proceed to solve for y with some algebra. And finally, we get now we have this as a solution, but we have the restriction that C3 is not equal to 0, and we notice that if C3 is not equal to 0, then this expression also never equals -1. You see that? Because the only way you get a -1 is if the first term in the numerator and the denominator are both 0. And that only happens when C3 equals 0. So here C3 is not equal to 0, and therefore y equals -1 is not included here. And also we made the assumption that this is the solution if x, or rather if y squared, 1 minus y squared, is not 0. Remember, we had to do the division here, and we had to assume that 1 minus y squared is not equal to 0. And what this means is that y squared is not equal to 1, and y is not equal to plus minus 1. And indeed, this general solution here may not contain this solution, these solutions, plus minus 1. And we don't know if that's a solution, or rather, those are solutions either. Now, this is our first case. So let's take the other case in which where 1 minus y squared equals 0. So if 1 minus y squared equals 0, then what we have is dy dx, and this is the given, and because this is 0, then we just have 0. And so we have y equals some constant c. But we know that this expression here is the same as y squared equals plus minus, or rather just plus minus 1. That is when you get the square root of this one. So y equals plus minus 1. And so we can say that c sub 4 is actually plus minus 1. So, to summarize, our solutions to the differential equation dy dx equals 1 minus y squared are, first we have what we obtained here, which is y equals c e to the 2x minus 1, c e to the 2x plus 1, where c never equals 0. So that's one solution, and another possible solution is y equals the constant plus minus 1. Now I have two remarks here. First is that the solution y equals 1 cannot be obtained from the solution with the c. So y equals 1 cannot be obtained. With any value of c. Value of c in y equals c e to the 2x minus 1 over c e to the 2x plus 1. So whatever value of c you choose, you're not going to get y equals 1. So that has to be stated separately as a solution. And the other remark is that the solution y equals negative 1 can be obtained by setting c equals 0. And what that means for us is that now we can remove the restriction, this restriction of c is not equal to 0. We can remove that restriction so that it will include y equals negative 1. And so our new solution would be now here c is any real number, so it doesn't matter. We can now use 0. And if we do that, this will now include y equals negative 1. But it will not include y equals positive 1. And so we have to write y equals 1 as a separate solution.
Please hit subscribe.